In your pre-calculus classes, you are going to be graphing a lot. And one tool online that's really wonderful is Desmos.com. This video is giving you a basic idea of how to use it well, just to graph some functions that would be hard to graph by hand. We'll just do a couple of examples. This first example is a quadratic. We're going to go ahead and graph it on Desmos. I'm going to open a new tab, go to Desmos.com, and if you want, you can go ahead and sign up or log in if you want an account and kind of be able to keep some things. But you also don't have to do that at all. You could just hit graphing calculator and go straight to graphing it. So remember, this is the graph we are trying to look at. When we just type it in right away to Desmos, we get what looks like a straight line, which of course we know this is not a straight line since it's a quadratic and since it's not linear. But what that means is our values for our lowest x and highest x and lowest y and highest y are not really good for this particular graph. And you can use your fingers to zoom in and out if you have a touch screen, or you can use the plus sign and the minus sign. I'll go ahead and use the minus sign, that's zooming out. And I'm just going to keep hitting it until I see something. It still looks like a line. Oh, look, there's something. Okay, so what that tells me right now is that I have an x-intercept somewhere between 10,000 and 20,000. Notice that negative 30,000 isn't anywhere low enough for me to see the full graph. So let's go ahead and continue to zoom out. Keep going, keep going. So we can see the whole graph now. This is not a good graph, however, because you have all this space on the left-hand side, all this space on the right-hand side, and the graph itself is so skinny, it's hard to get a good sense of it. So we are going to change the numbers on the x-axis, and we'll probably leave the y-axis alone, since it does show us at least where the minimum point is, the lowest point. We already had talked about this graph goes between 0 and 20,000 at the most. So I'm going to go ahead and use my graph settings, and I'm going to change the x-axis numbers. Notice it goes from negative 300,000 right now. I'm not going to do that. I'm going to do maybe negative 2,000 and then go up to 20,000, and that's a much better graph. In fact, I might change it to 25,000 just so I can see it go up a little bit more. I'm going to go ahead and hit my graph settings again to make this disappear. Now I can move it around a little bit, and if I want to zoom in and out, it's definitely a better looking graph. You can also zoom in with your fingers. Now I'm doing it with my fingers. It also allows you to find x-intercepts and y-intercepts. If you click them, notice this one gave you the y-intercept. The x-intercept is so close it's kind of hard to tell that it's there too. I clicked it, there's the x-intercept. There's also another x-intercept over here. It'll also tell you the extrema, the lowest point, the vertex in this situation. And we have a really nice graph, and we have some good information about it. So let's go back to our slide. Here's what we found. The question was about finding all intercepts and extrema, and that's what we did. All that information is on the graph. We got it from Desmos. We have our x-intercepts, we have our y-intercept, there's only one. We know the minimum value is negative 208,303, of course, and it happens when x is about 8,333. And that's example one. Let's do another example. Let's graph this function, the cubed root of 0.005x plus 6, and again, let's go ahead and find all the intercepts and extrema. Go back to Desmos. I can get rid of this graph just by hitting the X, and I think since these numbers are made for my previous graph, I think I'm just going to reload this, put it back to the normal, relatively small numbers, though honestly the other one might have been better. And I went ahead and wrote a cubed root as a 1/3 power. And again, it looks like I have a line. So let's zoom out. I'm going to use my fingers this time. It still looks like a line no matter how much I zoom out. And you can see what the problem is. The problem is that the y values are actually relatively small given the x values. So let me zoom back in. Notice that the y values, they're definitely positive, at least for a while. It looks like the values are around 2 in terms of the y values, at least at the x values we're looking at. I'm going to go ahead and open this up, and my y-axis, I'm just going to look from -1 to 2 and see what happens. In fact, let's go -1 to 3. Let's make the x-axis go from, and we're just going to make the x-axis be really large. So let's start with -1,000 to 1,000. Okay, you can see that it's definitely not a line now. Let's zoom out at this point. Ah, look at that. See, now we can see it better. Again, when I zoomed out, my y values got a little bit too big, though honestly this isn't too bad, but I think I'm going to go back and change my y values. I think I'll go from -5 to 5. Just to make it look a little prettier. Let's find the intercepts by clicking. And my intercepts are -1200, 0. That's the x-intercept. The y-intercept is 0, 1.817. And you can see there's no high point or low point. There's no extrema. If I keep zooming in and out, it's going to have the same shape. It's not going to ever turn around. So here's what we found out. My x-intercept is -12,000, 0. My y-intercept is 0, 1.817. And there's no extrema.